was not automatic. You need to use your computer a lot. Many man hours was used in the, I don't know what the department was called, but they used many man hours to prepare all the macros, and we wanted to automate it. So we went for totally manual generating in the office. It was offline, but it was manual, very time consuming. So the idea was, we make it offline, everybody does, but we make it 100% automatic, going from the CAD file to the robot programs. You heard it, Kevin told it, other people were saying it, but I will now try to show you. So this was a short introduction to myself, and now I will introduce you to the software. So this is actually what you just saw. This is just a CAD file. And the whole idea by this product is that we wanted all the red lines to be welded with the gantry system, which I just showed you. We are offline, we're sitting in Denmark, we don't see the robots, so how can we see what we're doing? Therefore we made that we can simulate what the real world is doing. That's for the engineering and for debugging purpose, and then it's nice for you to see, maybe. Let's see. So I will now demonstrate how we are actually coming down from the ceiling, go into the task, and make the weld. But that you will also see with the cobot today, the real thing. I will also show the simulation of the cobot. But today you have the opportunity to see in real life, which I also have if I want to fly around the world, but I like to sit in my nice warm office. Good. Sorry, I just forgot what I'm looking for. Oh, we'll do that. So actually, I would like to simulate this one in here. So we have all these things, we split it into A1, B1, C1, and so forth. And now I would like to show you, for example, we have a big open box here called C11, that's a good one. So I just click it twice, and now you can see that nicely open box, all the green is actually weldable, and I can simulate what is happening in the real world. We also have to the left some technical details for what value is the robot, what joint values is it doing, and stuff like that. All technical debug purpose, but it's only made for debug purpose and for making a nice show for you. See here, simply just weld a color plate. For now, the cobot system is not welding color plates. That's a little bit further out in the future, but the goal is there, of course. So how do we actually go from the CAD files to have the program which we can execute on the shop floor? That I will now show on a very overview introduction, because I cannot go into the detail here, but if somebody is interested in having a very detailed question, you can just come and visit me and my colleague Magnus. We are here for you. In RINAS, the package is a very open system. It contains rules, and it contains rules from different demands. The welding engineer is maybe having a demand that he says, I want to do special when I go around the corner. It can be somebody is having an idea that they want the production to be fast, or they want to go in a different sequence or stuff like that. All kinds of demand can be given to the software. We set that up in front when we're delivering the system for you. Together with the application engineer, you can set it up completely. When you have the system, you can just use it as it was delivered. Or you can proactively go in and change it on a maybe weekly basis or something like that. You could also have service visits from our customer service department saying, hey, we are having this and that, if we tweak this, we can do better, and then we find a solution for you. It's not a closed system. It is your system. And now, because we have all these things you can do, and you don't need them in daily production, we made a wizard with some few steps in here. And I will now go through the steps, and now you can say, hey, that's 10 steps. Okay, yeah, but let's see, we go through the steps and we find out why there are actually 10 steps. The first you need to do is you need to take your product, into RINASWELD. So you need to import your CAD file. And in here we have an interface which we should modernize a little bit, because that's a lot of things which the cobot does not need, but other customers do. So for now, you basically only need to press one button. And that I can do without shaking too much. And then it's doing the import. And depending on the size, it can take 1 minute or 2 minutes, or maybe even 3 if it's really big. And I'm just now showing it live, and it will, I cannot even remember, I think it was, now we see the time. I don't assume that everybody can actually see the time down there, so I will a little bit say that up here we have some status about what did the system do. It imported a CAD file. Oops, I closed it. Doesn't matter because we made it that you can open it again. There we have it. So what the system did, it was importing roughly 5,500 weld lines. And that's actually 1.3 kilometer of weld. And it did it in 16 seconds. And I think, okay, I can spare 16 seconds for waiting if I can really have such an amount of weld meters. We are in the import, we first import the data into our own native format. And then we go in and analyzing it, finding out where do we want welds, and a lot of information which the system internally needs in a later stage. So it's not only the pure import, it's also checking that the file is correct. And we actually are having errors and warnings. And in here we have no system error. That's good, because that means my team has made an error. So we never want that to be higher than 0. Then there's major error. That could be that in the CAD department, that they maybe draw two things inside each other or something like that. We will warn you up front, so you can go in and see that. So, but in here we have a good day, because we only have warnings. And you know, if your car is only flashing a little bit, you don't care. Only if it's red or the engine sign is doing something, then you care. So in here I don't care. So I just close the box. We have another one here because But now we have imported this file, and we have already analyzed here where do we want to weld. It's all the red lines. But you need to place this huge block in your production facility. And do you want it to be orientated east-west or north-south? What do you want on your shop floor? We cannot predict that in our software. So you need to tell it how do you want to orientate it. So we unfortunately need to ask you a little question here. First you say, which line do you want to have in X? You press a line over here and say, that's X. Then you press another line and say, that's Y. And then you could say you have, on the shop floor, you have different markings. It can be that you say, if I have a huge one, I want to have it lay at the 0 line. If you have a small one, you want to have it on 2 meter. It's something you can decide depending on how your shop floors look like. So we just give it option here. And again, technical detail, which is just fine. So now we know where the product is. But the thing is, this is a very huge CAD file. And when the software began, we had 640 kilobytes of memory. So we could not handle this in one task. So we split it into two smaller tasks. And for that, we made something called segment definition. Unfortunately, we made a small spelling mistake here. We called it manual, but I said it was automatic. But the thing is, it is automatic. It had already split it into segments. But the manual part is what if you have something in the CAD file which fooled the system a little bit, so you have the option to go in and see like, that you can improve it a little bit, because maybe you say, I don't want to have these tasks, but you can have whatever reason for changing it slightly. This process will maybe take you 5 to 10 minutes. And again, 1.2 kilometers of weld, it's not, in relative, it's take no time. So now we have done that. Then you want to give it to your shop floor logistics system, ARC5 or 4 or what you have. So we need to give it some kind of name so you can identify it later. Could be you want to give it a CAD file name or the date of the time, or just call it demo. Call it demo. Not like that. Maybe. We call it my name. Why not? I'm proud of it. So now it has a name. Then in the CAD data, you could have data about what A size do you want, what leg lengths do you want, what amperage, what speed. You could have all these information in your CAD file, but what if you haven't? What if your CAD system is not have that data yet? What do we then do? Then we make some rules, and when you're welding, your welding size, I just need to turn this off like that. What leg lengths you're having is depending most often of the size of your plates, and of course also where in the ship is it, so which strength does it have. So one basic rule could be, okay, the base plate is 10 millimeter, and the profile are 8. So you say in that combination I take a leg length and 4, but if the base plate is 12 and the profile is the same, then you go for 8. And that's just rules we're having, and that we can set up together with you. But in daily production, you don't need to go into your rules, because your CAD file is having the same demand every time, unless that you're now in a complete or a section of the ship. So, but in daily production, you will have to use the same rules. So we just make a tiny button here, say apply the rule. Then it's the same if you CAD data. This is the old ATX, the Tribon format. That does not contain bevel information, but in the CAD data, the naming of the profiles is very unique. So if you have a certain combination, then we can actually go in and apply. Do we have a V-shaped weld, or what do we have? We made an interface for this customer. Other customers not having that rule. But again, depending on your need, we make different rules. So we did that for this Japanese customer. Also, again, they have no information about how many layers they want to have. So we made a rule for that. So basically now we have done 7 steps, maybe using, depending on this one up here, 10 minutes. So now we're actually ready for generating. When we delivered this system in 2030, around there, the generation time for these 1.2 kilometer was 13 hours, because we had using one core and the old Windows 32-bit. So that was then. Then a couple of years later, Windows 64-bit was being delivered and rolled out to everybody. You all now use it. And that gave us, that was slightly 70% faster or something like that. So we went from 12 to 8 hours of welding. But that's offline time. And I assume that everybody are sleeping the 8 hours that everybody's recommending. So, so we're good. You can just go to sleep, and the next morning your program is prepared. But then AMD and Intel said you can have more cores. So now you're all stressed because your computer can do a lot more than you can handle. So what happened was, when I press generate here, and I normally can take a nice nap, it's just spreading all the workload to the whole computer. And you can see I want to sleep, but the computer here is not going to sleep. This is the percentage you have here in the corner. To who in the back, you cannot see it. Right now the CPU is using 27%, 35, 40, still climbing. Soon it will go to 100, but it's okay, I have a break. But my problem now is that I will now be finished in 15 minutes, so no sleep for me. But we don't have 15 minutes to wait. So I will stop it in a few seconds. Because for me as a technician, this is really nice. But for you guys, not nice to know it's finished in 15 minutes, you want a longer break. Do anybody have a small question for now? I am open for one or two. Anybody there? Or otherwise, we are at the booth, ready for question, and then we can take it one-to-one. If you have colleagues, they are also welcome, of course. I will stop it for now. It says, are you sure the computer really wants to work? But I stop it. It cleans up its memory. Now it says it's a total failure. I disturbed it. So I will open it again. I cheated a little bit and prepared it this morning. The one who can see the timestamp can actually see that I did it during my morning break. I had half an hour, so it was fine. So in here we have the statistic. It's a hard one. It says 15 minutes and a half. It says that it says that the system going down from the ceiling, welding down and going up again. For all the welds, how many welds are there? There is 4,107 welds. And it will take the system 120 hours to weld if you have one robot. But you saw the big gantries, you can purchase them with 8 robots. Or maybe even if you're really critical, you can have it with 10. And that makes it easier for me because then I can divide with 10 and that says then you'll finish in 12 hours if you have 10 robots. So that is in a nutshell what we were doing in the old days. And I have already simulated, so there's no reason for me to do it again. But I will simulate at least one task. And I prepared, and I write a small note for myself out here. You should take the 8 angles. Okay, now I do that. E8. You see, this is a small one. Only 800 millimeter from one side to the other. The software never gives up. It does. It is not generating forever, but it really tries its best to weld. But as you can imagine, if I get smaller, or even what if I close it, make a sandwich construction, and that's what ship is, then we need to do something. So what we came up with was, what if we did detach? Simply take the robot down from the gantry, throw the gantry away, or don't build it, maybe even smarter. Make a magnet, place a magnet, and put the robot on top. And then we just said to the software team, you have no freedom anymore. You need to stand in here on the floor, no height. So that was a little bit of a challenge for us. But we achieved, we managed, so we're good now. So now I will actually show you how do we take a panel like this, and instead of a gantry system, we take a magnet, actually 2 magnets and a cobot. And that's where I'm going now. But now I need to see a little bit my time. I should be good now. So this was just introduction to what have we done in the past, and now the future will come. I took the box which Kun is making, and I should also have 5 minutes to show that. Just a reminder for myself. So first I briefly showed that we took this panel from Royalty, and my colleague Kun was actually going in and generating for all the welds. In this case, there was only 2 tasks because it's a very small items. One of them took 13 minutes, and the other one was unfortunately taking an hour. We are not finished in optimizing one with an hour, but it's just to tell you a little bit about our software, because what is actually happening in here is, I will now show the home. You see, this here is, we have 2 tasks, and you would say, but it's roughly the same, Anders. No, if you see this one in here, we have 3 plates, really no space, and if you go look in real life, there is not much space. But in this one here, there is 3 holes. So the software will try to mingle around, and therefore it will faster find solution. And that is what I will now show you, that it is actually having a hard time, but it's doing it anyway. But let's take the very worst one and then simulate that one and just start to see what it's doing. See, it's already, it should stand still. And then for the one down in the back, I will do it even bigger. Can you see all the way down there? Yeah. There's a thumbs up, at least one. So this was a little bit an extra challenge that we are now going into even smaller places than ever. And by the way, we are 100% sure that there is no collision. All parts of the robot is having different collision sets. So for the big part of the robot here, we are ensuring that we are 15 millimeters away from everything. But for the tool, we cannot be 15 millimeters away from the gas cup. It really needs to go as close as 1 millimeter to the material. All parameters you can decide yourself, but we are in control. We are not hitting anything. What we normally do is we can go visit the customers and we can see if the paint is still intact, and normally it is. I don't know how we can check it with the universal robot because they have no paint. So, but we are generally not colliding. And if you are colliding, send us a project, send the file to CSD, Customer Service Department, and we will iron out the error, because collision is not acceptable. Now I will do a short generation of something similar to what Kun will show you later. Not exactly the welds which Kun is having, because I wanted to show you a little bit more. We have different reasons for what we want to show what we want. Kun needs to do it in real life, so he wants to find some welds which way you actually can see it. But I'm more free because I can zoom in as I want. Open it here. So I selected these 4 welds, and I just prepared it, and I used the wizard, which you already are borrowing to see. You only saw it once, but you don't want to see it again. And if you want, we show you at the stand. So I get it ready for these welds, and I can do it. It takes 8 seconds. So why say that it takes 8 seconds if I can just show you? I'm a little bit lying. It was 11 this time, but it's in that neighborhood. But the new thing is, now we have fixed position. Before, the gantry was just moving around as it wants for the double hull, 3 axes of freedom. When we make the panel line, we took 1 freedom away from us, so now we have X and Y. And now you took the last freedom away, you said stand still. But we are free. The RINA software are deciding where do we want to stand. And we are exporting information to the ARC system, telling where we want the robot to stand, or we are drawing where we want the backers to stand up front using the plasma marking system, which you already are using for marking where you want your profile to be. But we will find solution together with you how to make a good position for you In here I have one position and it takes all 4 welds. And I should have shown this in Kun's project, and I will jump back, and just before you go, I will show you that we have all these systems for the entire block that Kun was having. This is 4 welds in one position, and then we can just nicely, you can buy the system and see it for yourself in real life. I just have the software. And again, you don't need to see this. This is not for collision checking. This is only for debugging purpose and for you today here. Our system is also capable of running, of course, 100% automatic, so you don't need to watch your production. If there's a stop, the system will call and yell for you, because nobody really wants to look at this at all, only once. So I will stop it for now. Is there anybody who wants to have me zoom in anywhere? Or you can also just come to the stand. Okay? Now everything is, one last thing I forgot before was we have an export sending to the shop floor system. But that's of course really needed. I promised you one small one, which I've skipped, and that was take the ventilation box prepared where Kun was saying I don't know, he was saying I don't know what I want to weld, so he was just generating everything. So in here we can go in and see all the positioning in here. And again, only for visualization and for debugging purpose. Just see. This is a new thing that we make. Okay? Did I cover everything, Kevin? Any remarks?
No, you did it very fine. Thank you very much. I really appreciated the demonstration, the live demonstration. There's more into that, into the hard